So our Unit 3 test is coming up, and this is to help you study. So if you have not attempted these problems yet, you're watching this video and you haven't tried every single problem yet, then please stop the video and go try the problems, and then come back and watch the video afterwards. You really should not watch this video until you've tried these problems on your own. That's going to be the most helpful. Then after you finish the video, like as you go through it, correct your answers, but kind of mark those questions, and then go look at the blank PDF of this file that's posted on the Google Classroom. And the next, maybe tomorrow or in a few hours, try those questions that you got wrong. Try those questions again. Okay, and then just a reminder, the very last question, I forgot what number it is, but the very, very last question, question 14, we're skipping. It's not going to be on our test. We're gonna save that for another chapter. So, anyways, jumping into this, first question gives us f of x equals x to the 2/3, and it says find f prime of 0, and then sketch a graph of the function, and use that to explain your analytical result. So, we're going to take f prime of x is equal to 2/3 x to the negative 1/3, which is 2 over 3x to the 1/3. And if we want to write that in radical form, 2 over 3 cube root of x. Okay, so f prime of 0 is going to be 2 over 3 times the cube root of 0, which is 0. So it's 2 over 3 times 0 is 0, which is undefined. So we want to make sure that we're boxing what we need to box. Find the value. That's our value. It's undefined. Then sketch a graph. So if we sketch this graph, this is a graph that we should have memorized. The y value is 1. And if you don't have this memorized, it's really easy to memorize. Just kind of remember the 1/3 power graph is basically a square root and a flipped square root, and it has that, basically we called this a vertical tangent right there. So that's our 1/3 power graph. And then our x to the 2/3 power graph is what we're about to do, and that's where we have a square root and then it's flipped sideways. So it's basically flipped vertically. Now the +1 will just mean that it's upward. So that's a sketch. It doesn't have to be perfect, it's just a sketch. You're just kind of memorizing what those two graphs look like. Okay? And really anything with an even will be that same pattern, and anything with an odd will be the same pattern for our cube roots. So anyways, use this to explain why. So we got undefined, right? And this goes back to that differentiability rule, right? It was a cusp. So we can say, using the graph to explain our result, the graph of f of x has a cusp at x equals 0. So f of x is not differentiable. Therefore, f prime of x is undefined. And then that's the what at x equals 0. We just need the what and the where. Okay, next one is our square root graph. So find the value of f prime of 2. So first we're going to do f prime of x. We get 1 over 2 square root of 4 minus 2x times, right, this is a box, times negative 2. The 2's will cancel. So this gives us negative 1 over square root of 4 minus 2x. Now we want to find f prime of 2. So f prime of 2 equals 1 over negative 1 over square root of 4 minus 2 times 2 is 4. So negative 1 over 0, which is also undefined. So again, we're going to box this. Same thing is draw a sketch. We need to have the square root graph memorized. The normal square root of x graph, right? Y equals square root of x. That normal graph looks like this. Now, if we had y equals square root of negative x, that's just flipped backwards. And what does the 4 do? Like when we add 4, that shifts it 4 to the This is a little bit weird because the negative. So if you get this one wrong, it's okay. But here's the easy way to think about the intercept is let's just find the intercept. If I plug in 0, the square root of 4 minus 0 is the square root of 2. So we get basically the square root of 2. So at 0, we have the square root of 2. So somewhere up here. But then the opposite would be if we set it equal to 0 to get that other intercept. So the square root of 2 is our y-intercept, so that's somewhere like in between 1 and 2. But the square root of x, that's the one I'm more worried about because that's where it starts. So the square root of 4 minus 2x, if we equal it to 0, when does 4 minus 2x equal 0? That's at x equals 2, right? Add 2x, divide by 2. So at x equals 2. And it's flipped to the left, okay? So that's kind of what our graph is doing. Now, basically, our key here is just saying the graph is not continuous, right? This graph of f of x, it's not a cusp, it's not a corner, it's actually just not continuous. So the graph of f of x is not continuous at x equals 2. Therefore, or we'll say the same thing. So f of x is not differentiable. Right, if it's not continuous, it cannot be differentiable. As soon as it's not continuous, stop, it's not differentiable. Therefore, f prime of x is undefined at x equals 0, or 2, at x equals 2. So, if you're a little confused on these first two, what I highly recommend is jumping back up to your notes on differentiability, and where we had these 3 graphs here, right? And kind of looking at these 3 graphs, like a square root one, it's normally going to be because it was just not continuous. Then to the first, like to the 1/3 power, that's going to be because of that vertical tangent line. We had that vertical tangent line there. And then an even like 2/3 power, that's going to be a cusp. So you need to know those 3 graphs for our exam. And I would review those 3 graphs. Okay, square root, not continuous, 1/3 root, vertical tangent, 2/3 cusp. Okay, and then also, the differentiability, we also might have some piecewise functions with it. Okay, find each of the indicated limits below, and hint, remember the definition of the derivative, and the alternate definition was that one at a point, when we plugged in a point. So this is just the regular definition as h approaches 0. It's just saying, basically f of x equals ln of x, find the derivative. So f prime of x for this case would be 1 over x. Right, that's just one that we memorize. Okay, our next one is same thing, as h approaches 0, and this time we have, basically what you can do is kind of just grab this guy. So we have f of x equals the cube root of 2x minus 3. We cannot do the shortcut because it's a cube root, not a square root, so we need to rewrite this. 2x minus 3 to the 1/3 power. This is going to be chain rule because it's not x to the 1/3, it's some other box to the 1/3. So we're going to say f prime of x is equal to 1/3 times that box times 2x minus 3 to the negative 2/3 power times 2. And I'm okay with you guys leaving it like this on free response. That's perfect on free response. Now, if this was multiple choice, at least it would probably be 2 over 3 times 2x minus 3 to the 2/3. It would probably look like that for multiple choice. Okay, normally on multiple choice, they honestly don't put the radicals back in. Okay, now this next one's a little bit different because it's not h going to 0, it's x going to pi over 2. But when you see this x minus pi over 2 business, you need to remember, hey, wait, that's the definition of derivative, but at x equals pi over 2. So basically what that means is they want you to first find f prime of x, but then plug in pi over 2. That's what this one's asking. So for sine of x, so basically f of x equals sine of x. So what's the derivative? Well, f prime of x would be cosine of x. Now we have cosine of x, now let's plug in pi over 2. So cosine of pi over 2, and that's just 0. right? You memorize on your unit circle. Up here is 0, 1. It's the 0. Okay, and then the last one is another one of these alternate forms. Okay, and this one does have h of 0 again, but there's no x value. You see there's no x value. When there's no x value, basically where the pi over 4 is, that's the x, but you're going to then plug in pi over 4. So it's actually almost the exact same thing as the last one, but now we have cosine of x and it's a different point. So we have f of x equals cosine of x, and what we want is we want to know what is f prime of pi over 4. That's what this question is asking. So we need to be comfortable with all of these forms. The first two were the original two forms, and the second two are alternate forms for plugging in a point. So f prime of pi over 4, first we're going to do f prime of x. The derivative of cosine is negative sine. And then we're going to plug in pi over 4. So for pi over 4, it's square root of 2 over 2. So negative square root of 2 over 2. Okay. So before you take your test, please, please, please memorize your trig table, right? The sine, cosine, and tangent. That trig table, you're going to need to know that on your test, right? So make sure you go back and have this memorized. Okay, next one, the equation to our normal line. So normal line, meaning we need that perpendicular slope. So you have x1 and y1 and m. Now, we were not given an x1, we were given an m. dy dx is our m. So when the m is 2. So how are we going to do that? We need to take the derivative and set it to 2. So we have y equals e to the 2x. So we're going to do y prime equals, now the derivative e to the x, that was our easiest derivative, was just e to itself. But then chain rule times 2. We're going to set that equal to 2. It's going to be e to the 2x is equal to 1. How do we get rid of an e? How do we solve for an e? This was back in our review chapter. We get rid of an e, we solve for an e by taking the ln of both sides. The ln and the e cancel out. So on the left side we get 2x. And ln of 1 is something we should have memorized. ln of 1 is always 0. So this gives us x equals 0. So our x1 is 0. How are we going to get y1? To get y1, we plug it back into the original. So y equals e to the 2x, that's the original. So to get y1, we plug in e to the 2 times 0 is 0, and anything to the 0th power is 1. So our equation is going to be y minus 1 equals 2 times x minus 0. Now these are solved for y equals, so we just need to solve it. So y equals 2x, add the 1, plus 1. So we got c. Oh wait, not c. It's not c. Because, it's my fault. We wanted the normal line, right? So I totally messed this up. We wanted to have the normal line. So I think I actually messed this up kind of from the get-go. But, it's actually an easy fix. Just instead of 2, the x1 and the y1s are always the same. So the x1 and the y1 are always the same for normal line and tangent line. So this just wasn't m, it was m perpendicular. So instead of 2, we're going to use negative 1/2. So c was a good distractor, but a is the right choice because that has the perpendicular slope. Okay, next question. Given that f of x equals x squared e to the x, what is the approximate value of f of 1.1 if you use the tangent line of that graph? We're going to do x1 is 1. For y1, we're going to plug it into the original. So f of 1 equals 1 squared e to the 1. And so we get e. And for m, we're going to have f prime of x equals x squared, right? So, sorry, this is product rule. So we're going to have 2x and then times the original, e to the x, then plus, now we're going to leave x squared alone, and then we're going to do the derivative e to the x is actually just e to the x again. And so we're going to plug in f prime of 1. So we're going to get 2 times 1 is 2, e to the first power, plus 1, e to the first power, which is 3e. So I'm going to just write this as 3e. So what's our tangent line? Our tangent line is y minus e equals 3e times x minus 1. And so then we're going to do f of 1.1 minus e is approximately equal to 3e times 1.1 minus 1. And we're going to get f of 1.1 minus e is equal to basically 0.3e, right? 0.1 times 3 is 0.1. So we get f of 1.1 is approximately equal to 1.3e. Okay? And I know these are all decimals. You'd have to type this into a calculator for this one. On the exam, we're not going to have any decimals, so you're not going to need to worry about this. But if you basically, go to a calculator and type it in, right? I have a, my graphing calculator here is just basically, it's e to the first power times, we said 1.3, that gives us 3.534. So that's how you would do that one. Again, on the exam, I won't do anything with these e's for plugging in, and we won't do anything with decimals. Okay, so next one, we want to find the derivative of f prime of pi over 2. So first we're going to do f prime of x. Now, before I do that, I'm actually even going to rewrite this. So f of x equals, now the 5 is going to go outside of my parentheses. It's not squaring the 5, it's only squaring the cosine. So 5 cosine of pi minus x squared. So if I took the derivative, that very outside is that 2. So 10, right, the derivative of like 5x squared would be 10x, but we have this big box. So 10 times cosine of pi minus x. This is chain rule. Now, the next outside is the cosine. What's the derivative of cosine is negative sine pi minus x. Now we actually have another box, so we're going to do chain rule again, times negative 1. Right? Why times negative 1? Because the derivative of pi minus x would be negative 1. Pi is a number, but the derivative of negative x is negative 1. So this gives us, now we have two negative signs that are going to cancel out. So positive 10 cosine of pi minus x sine of pi minus x. Now we're going to plug in pi over 2. And we're going to get 10 cosine of, now pi minus pi over 2 is just going to be pi over 2. And then times sine of pi over 2. Now at pi over 2, cosine is 0 and sine is 1. So this is 10 times 0 times 1, which is 0. Okay. Next one. For what values of k does the graph of g of x equal k e to the 2x plus 3 have a normal line, right? So that perpendicular slope. So we're going to do x1. It's 1. y1 we don't really care about right now to write the equation, but we are going to care about to solve this, and then m. So we want to be careful because it's a normal slope, so we want to make sure we flip that. So the slope is going to be 5. Okay, and then so we want to know, when does this graph have a normal slope? So g prime of x is going to be equal to, now this is e to the 2x. We're not going to bring the 2x down, that's not what e's do, they stay the same. So k times e to the box, so e to the 2x, but then times chain rule 2. Then plus, right, the plus is like a separator. We're not doing any rule, like no product rule, no quotient rule, just a separator. What's the derivative of 3x is 3. So this gives us 2k e to the 2x plus 3, but we know that we want to set this slope, right, this is the slope, we want to set this slope equal to 5, because that's the normal slope. Subtract 3 from both sides, 2 equals 2k e to the 2x. We want to isolate the e. Divide by 2k, we're going to get 1 over k, right? We want to divide by the k also. So we're going to get, oh no, sorry, we're trying to isolate for k. This is my fault. We're trying to isolate for k. So what we can actually do is we can plug in, we know x is 1, so we can just plug that in, right? So we can plug that in. So we can say 2 equals 2k e to the 2 times 1 is just 2. So now let's solve for k. So first I'll divide by 2. 1 equals k times e squared, and then we can divide by e squared. So 1 over e squared equals k. So that's our answer, 1 over e squared. Right. Next one, we have a graph, and we're going to use this graph, and this is the graph of f prime. So this is a little bit, going back to last chapter as well. So what type of polynomial is f of x? So is it, square, like basically a quadratic, a cubic, a quartic? And we know that if something has basically two terns and 3 zeros, right, that's a cubic. So now f prime of x was basically f prime of x was cubic, and that's always one less. So they wanted to know, what about f of x? So this is a little bit tricky, but if you guys kind of remember, we did this where we had if f of x was like something squared, then f prime basically became like to the first power, right? And we know basically f prime of x is going to be something with like an x cubed. So f of x would have had to have like an x to the fourth, because when you take that derivative, it becomes like 4x cubed, if that makes sense. So basically what we're saying is f prime of x is cubic, right, like degree 3. So f of x is quartic, right, to the fourth power, like degree 4. You could just say degree 4 if you don't know the word quartic, because f prime of x is 1 degree less than f of x. Okay, so what degree? It was quartic. Okay, at what values of x does the graph of f of x have a horizontal tangent? So again, this is a little bit review from last chapter, but horizontal tangents happen when f prime of x was 0. So this is going to be at -2, at +1, and at 3. So f of x has a horizontal tangent at x equals -2, 1, and 3. Why? Because f prime of x equals 0 at those points. Okay, we still are going to be tested on last chapter. These two chapters kind of merge together, so we need to make sure that we're still remembering last chapter. When is it going to be increasing? Well, increasing was when f prime of x was greater than 0. So greater than 0 is going to be where it's above the axis, because we already have the f prime graph. So f of x increases for -2 to 1, union from 3 to infinity. Why? Because f prime of x is greater than 0 at, or for those, we'll say for those intervals. Okay, where would it be decreasing? It's just the opposite. So f of x is decreasing for -infinity to -2, union 1 to 3. Why? Because f prime of x is less than 0 for those intervals. Okay, and then this last one does not have to do with our graph. Find two values on the interval from 0 to 2 pi where the graph of f of x equals cosine of 2x is equal to square root of 3. This is kind of a little bit of a bonus because I know we're just not as good as with this 2x business, but we're gonna learn it, we're gonna practice it. So we do need to be able to take the derivative. So the derivative of cosine is negative sine of 2x and then times 2. So the derivative is -2 sine of 2x. And they're saying find two values on the interval where the slope of that tangent line is equal to square root of 3. Okay? So we want to set this equal to square root of 3. So we're going to divide by -2. We're going to get sine of 2x is equal to the square root of 3 over 2. Now, this is where I said this is a little bit of the bonus part, and we could definitely do this, and technically you guys could have done this because I just said find two values, and they're actually going to be up to 4. But the reason they're up to 4 is whenever you have a 2x inside, like sine of 2x, what that's actually saying is that normally we just think between 0 and 2 pi. But when we have a 2x, it's actually going to allow us to do one more revolution and go all the way up to 4 pi, which is a little bit tricky. But what you do is you just basically double your two answers. So what we want to think about is where on the table, like if we did inverse sine, where on the table for inverse sine does sine give square root of 3 over 2? So on that table, right, sine was 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. And this was at pi over 3. So it's in the pi over 3 slot. Now we have all students take calculus, so it happened at pi over 3 and 1 less 2 pi over 3. So those were the two spots. Oh wait, but I missed that negative sign, huh? So negative. So actually the negatives would be in these two. So it would be at 4 pi over 3, and at 1 less than double would be 5 pi over 3. So the original 2, which I think everyone could have gotten, and I only said to find 2 anyways, the original 2 would be 2x equals 4 pi over 3 and 5 pi over 3. Now, we have it as 2x and not x because of that 2x. But actually, we're allowed to go around twice. So actually, there are actually 2 more values, and we just double them. 8 pi over 3 and 10 pi over 3. We're doubling them because we're going around a second time. Now we're going to divide each of these by 2. So we get 4 pi over 6, 5 pi over 6, 8 pi over 6, and 10 pi over 6. And a lot of those will simplify, but those are our 4 possible answers. All right, I said just find 2 answers, but those are 4 possible. So that would give us x equals 4 pi over 3 pi, 2 pi over 3. I don't know what I'm doing. Divide by 2. 2 pi over 3. 5 pi over 6 doesn't simplify. 4 pi over 3 simplifies. Oh wait, did I mess this up? Yeah, I did mess this up. Okay, we can't just double them, it's my fault. So that's why this is a little tricky. You don't just double them, you have to actually think a little bit harder than that. So what happens is, this is going to be when we do the second rotation. And so if you just got these 2 answers, honestly, I just said find 2 anyways. So if you just got these 2 answers, you're golden. But just to show the couple of you guys who may want to see how to do that extra one, this is going to be 1 more than double, right? Double is 6, so 1 more than double, right? Like 6 pi over 3 is double, so 1 more than 6 will be 7. And then the pattern will just kind of almost continue from there. So, 7 pi over 3. 7 pi over 3. Okay, then now over here, this is like having 3 pi. So this is 1 less than triple actually. So if you triple it, it's 9. So it's going to be 8 pi over 3. Then this is 1 more than triple. Will be triple is 9, so 10 pi over 3. And this is 1 less than 4 pi. This is 1 less than quadruple. So quadruple would be 12, so this is 11 pi over 3. So those second 2, the first 2 from like the first rotation were 4 pi and 5 pi. The second 2 will be 10 pi and 11 pi. And if that really confuses the heck out of you, don't even worry about it. So our answers would be 2 pi over 3, 5 pi over 3, 10 pi over 3, and 11 pi over 3. Those would be the 4 possible answers, but I said just to find the first 2, so the first 2 are 2 pi over 3 and 5 pi over 6. Okay. So, oh wait, we got to divide by 2. So that's my fault. Yeah, we got to divide by 2. I didn't divide by 2. So when we divide by 2, we get 10 pi over 6 and 11 pi over 6. So the 10 pi over 6 can simplify to 5 pi over 3, and the 11 pi over 6 does not simplify. So again, this one was very tricky. The main thing that I really need you guys to know how to do is to take the derivative of cosine of 2x. Okay, I'm probably not going to have you solve anything on our exam. Just be able to take the derivative of cosine of 2x. I might have you plug in, but I'm probably not going to have you solve and do it backwards. Okay, this one, consider the piecewise function. If a equals -3 and b equals 4, will f of x be continuous at 2? So I'm going to show you kind of the easy way to kind of think of it in your head, but then what we need to write out. So the easy way to think in your head is just plug these in and see if we get the same answer. So negative 3 times 2 squared plus 4 times 2 plus 2. That's negative 3 times 4 is negative 12 plus 8 plus 2 is negative 2. Then in the bottom, negative 3 times 2 plus 4, we're going to get negative 6 plus 4. We're going to get negative 2. These are the same. It's going to be continuous. But we have to actually write out the 3 rules, which kind of sucks. So let's write out our 3 rules. Now, before I do that, I'm going to actually just rewrite f of x. So let's just rewrite f of x and let's just plug in a and b. So we're going to have negative 3x squared. This is going to be easier to look at, plus 4x plus 2 when x is less than or equal to 2. Then we're going to have negative 3x plus 4 when x is greater than 2. So I know my answer is continuous because I kind of cheated. I just plugged them in and I cheated. But I have to prove it with my 3 rules. So our first rule is f of 2. Now, the top side is less than, so that's going to be our left side. And it's less than or equal to, it's going to also be our equal side. The bottom side is greater, that's going to be our right side. So f of 2, we're going to be using the top side. So negative 3 times 2 squared plus 4 times 2 plus 2. And you can do all your workout, but we already did it and we knew that the answer is negative 2. Then our second rule, we're going to do the limit as x approaches 2 from the left side of f of x. That's the same thing. It's negative 3 times 2 squared plus 4 times 2 plus 2. And we got negative 2. Then we can do the limit as x approaches 2 from the right side. This is the bottom equation. So negative 3 times 2, negative 6 plus 4, we also get negative 2. So because of these two, we can say that the overall limit as x approaches 2 of f of x is equal to negative 2. Now we can move on to our third rule. Our third rule says that f of 2, in this case they are equal, they both were negative 2, is equal to the limit as x approaches 2 of f of x. So because all 3 of these rules pass, I could say exists, and then this was equal, we're going to say therefore f of x is continuous at x equals 2. It passed all 3 of our rules. Okay, now for differentiable we had 2 rules, right? These are new. Our first rule is that f has to be continuous, and f of x is continuous at x equals 2. Why? We just proved it in the last step. Now our second rule has to be with those limits, the left side limit and the right side limit for the derivatives. So before we do that, we need to take the derivative. So we're just going to rewrite the piecewise function, but with a derivative. So the derivative of negative 3x squared is negative 6x plus 4. That's going to be when x is less than or equal to 2. And then negative 3 when x is greater than 2. So the limit as x approaches 2 from the left side of f prime of x, that's going to be our top equation. So that's going to be negative 6 times 2 plus 4. That's going to be negative 12 plus 4 is negative 8. Then we can do the limit as x approaches 2 from the right side of f prime of x. You can see they're not equal, but you have to write it out. You just have to write it out. Equals negative 3. So now these are not equal to each other. So we could say f of x is not differentiable. Why? Because the limit as x approached 2 from the left side of f prime of x, that negative 8 number, did not equal the limit as x approaches 2 from the right side of f prime of x. You could have also, basically you need this written somewhere. You could have written this and then said therefore it's not differentiable. Oh, we also need the at. So make sure you have that at x equals 2. We always need that at x equals 2 because. So that's really important too, the where. So the what and the where and then the why. Those are kind of our 3 things, the what, the where, and the why. So anytime they ask you to justify, just think, do I have my what, do I have my where, do I have my why? My what is it wasn't differentiable. My where is x equals 2, my y is because those were not equal. So that's full points for justification if you have those three. Okay, and then for what value of a and b, so going back to here, new a and b, for what values of a and b will it make it both continuous and differentiable? Now, they also could have just said, will f of x be differentiable? And it would have been the same question. So just be aware of that. Is on the test, I might just say differentiable. But it's differentiable, what does that mean? It had to first be continuous. So this question is the one we did at the end of one of those homeworks, and it's always the same step. Set up a continuous side, so continuous for x equals 2, and set the originals equal to each other. So we're going to set ax squared plus bx plus 2 equal to ax plus b. And we're going to plug in x equals 2. So 2 squared is 4, so 4a plus 2b plus 2 equals 2a plus b. And if you want to solve for one of them now, you can, but we don't have to. That's our first equation. That's kind of like our equation from our continuous. Now we need to get an equation from the differentiable side. So the differentiable side, we already did do the derivative, but I did the derivative when I plugged it in. So we got to retake the derivative with the ax part. So f prime of x equals, so again, the reason we can't use this one is because that one we had plugged in -3 and 4, but we're not using those anymore. We're using new values. So 2ax plus b, right, we're doing the derivative ax squared, will be 2ax plus b when x is less than or equal to 2. And the derivative ax is just going to be a, the derivative of the b part goes away when x is greater than 2. So we're going to set those equal to each other. So 2ax plus b will need to be equal to a. We're going to plug in 2 for x. So that's 4a plus b equals a. So this is our second equation. So to me, the easiest place it looks like to solve for is for this b. But what I am going to do is I'm going to simplify the other equation, make it easier on myself first. So just kind of subtract the 2a, right? Maybe subtract the b. So 2a plus b plus 2 equals 0. Kind of just combine like terms before I plug in is a little bit easier. You don't have to, but it makes it a little bit easier. So let's solve for b on this second equation. Subtract 4a from both sides, we get b equals -3a. So we're going to take that guy, we're going to plug it in for b. So actually, let's do this to save us room. So this gives us 2a plus -3a plus 2 equals 0. That gives us -a plus 2 equals 0. Subtract 2 from both sides, -a equals -2, or a equals +2. Now that we have that, now we can plug in over here, right? B equals -3 times 2, and we get b equals -6. So there's our answer. If you have extra time, you can always go back and plug these in. You'll plug back in 2 and -6 into the original equations and make sure that you get the same answers. So you plug in a is 2, b is -6, and x is 2. You plug in all three of those numbers into the originals, make sure they match. Then you can plug in 2, -6, and again x equals 2 into your derivatives and make sure they match. And if they both match, you did it correctly. So basically, just kind of a little bit extra of things that we need to make sure we have memorized for this test. So, for this exam, right, kind of prerequisite that we need to make sure that we know is, kind of review from other chapters. So we need to make sure that we know our sine, cosine, and tangent charts. Basically plugging in those values, right? We need to know that chart. We need to know that ln of 1 is equal to 0, and that ln of 0 is undefined, and that the ln of e is equal to 1. We also need to know that if we have e to the 2x like equals 4, or I'm never going to give it to you that, but I might say e to the 2x equals, say, 1, we need to know to solve that we would need to do the ln of both sides and we get 2x equals, now ln of 1 is 0, so we'd get x equals 0. I also might have instead, the ln of e to the 2x equals e, and when we take the derivative of those two, or sorry, just e to the 2x equals e, that's my fault. When we take the ln of both of those, we get 2x equals 1, so this would be x equals 1/2. So that's going to review. The other review that we need to know is we need to review everything about derivatives. So we need to know the whole limit as h approaches 0 of f of x plus h minus f of x all over h is the definition of the derivative. We also need to know the alternate forms, right, which we have up above. So, it could be going x to a number, or it could be going, h to 0, but with having plugged in the x here. So both of those also will work. So that's when you plug in at a point. So we reviewed that in one of those above examples. We also need to basically memorize that table from the other chapter of the justifications, where we had a horizontal tangent happens when f prime of x equals 0, right? Like increasing happens when f prime of x is greater than 0. Decreasing happens when f prime of x is less than 0. And a max and a min, right? Max is when we go f prime of x basically positive to negative, and minimum f prime of x negative to positive. So that can still be tested. Okay, and then another thing that can still be tested as review would be our continuity, our 3 continuity rules. Okay, and if you're watching, I may even throw a limit on here, and I might do one of those limits as x approaches infinity. So just remember those rules: is the numerator bigger, is the denominator bigger? That might be thrown on just as a test. Okay, so that's everything that's reviewed. Now from this chapter, what do we need to memorize? So from this chapter, we need to have memorized, now we already know power rule, that was before, but we need to know product rule. We need to have quotient rule memorized, and we need to have chain rule memorized. Make flashcards if you need to. Okay, we also kind of need to know when we have these kind of combined, like when they're combined. And the day 21 homework is a really good homework to review. So that goes over a lot of those combinations. Okay, a second thing, and this is kind of optional, but I think it's really helpful, is to have that reverse power rule, like say 3 over x to the 4th power, f prime of x. The reverse power rule says multiply it up and add 1. So reverse power rule. And then also the square root rule I think really helps. So if we have the square root of x, then f prime of x is 1 over 2 square root of x. So I think these two help, but they're not mandatory. Then our third thing we need to make sure we have memorized is we need to have all of our trig derivatives. So our trig, oops. So basically if we have f of x and f prime of x, kind of memorizing the derivative of sine of x is cosine of x. Derivative of cosine of x is negative sine of x. Tangent of x is secant squared. Then I'm going to group tangent with cotangent is negative cosecant squared. Then secant of x, right, 1 over cosine, is secant x tangent x. And cosecant of x is 1 over sine, is negative cosecant of x cotangent of x. So make sure we have those memorized. The fourth thing to memorize is going to be the derivatives of e to the x and ln of x. Right? If f of x equals e to some box, f prime of x is e to the same box times the derivative of the box. And then if f of x is ln of a box, then we know f prime of x is 1 over that box times the derivative of the box. Okay, next thing we need to have memorized is the inverse derivative. Which is kind of the weird one, which is basically the derivative of our inverse function is equal to 1 over f prime of the inverse function. So that was that rule. Review those notes if you need to. And then the last thing is going to be the differentiability. So kind of knowing both the two rules, differentiability. So there's two rules, like the continuity rule and the limit from the left side of the derivative equals the limit of the right side derivative, but then also kind of the graphical cases. So knowing, the discontinuities are not differentiable, knowing that cusps and corners are not differentiable, and then also knowing that vertical tangents are not differentiable. And finally, knowing that if I tell you it's differentiable, that means it's continuous. So if I said a graph, a multiple choice question, I said, f of x is differentiable, which of the following must be true? Well, it must have been continuous. And if it's continuous, what else is true? Then these three rules would also be true. So if I said like f of x is differentiable at x equals 2, then do we know that f of x is continuous? Right? Yes, we do. Do we know that f of 2 exists? Well, that's one of those three rules. So yes, we do. Do we know that the limit as x approaches 2 from the left side of f of x equals the limit as x approaches 2 from the right side of f of x? We do, because that's going to be the second rule. That's going to be kind of that the limit as x approaches 2 of f of x exists, but the way we find that rule is what I just wrote in C. Right? Now, do we know that f of x has a minimum at x equals 2 if I just told you that it was differentiable? No, we do not know that. We only know that it's continuous, and because we know it's continuous, we know about those three rules. So that could kind of appear on the multiple choice. So that's a pretty good list of things to study. You guys probably have some flashcards that you might want to make to make sure you have all of this memorized. And then, like I said, I would go back through the test, redo these practice questions, and redo any questions that you got wrong, and do them over again, and just kind of study what we did. Okay, good luck with your studying, and don't get too stressed about the test. Just practice this, memorize it, and then